Okay, today I want to start with a review problem from yesterday. On yesterday's worksheet, we were doing problems where I'd give you a point, and then you figure out where that point would be, draw a ray to it from the origin, and then you draw the reference triangle that goes with it. You label all three sides of it. Granted, the point's telling you two of those sides already, two sides of the triangle. Once you've got all three sides labeled, you use the reference angle to find sine and cosine of theta. I'll pause for a second while you give that a shot. Okay, here's how you should have done it. 2, -7 is in the neighborhood of there. I draw a line to it. Okay, now I have to drop from there to the x. Then I make my line across, and I've got my reference triangle. 2, -7, and what? That's the square root of something. Square root of 49 plus 4. I'm squaring each side and adding them. 49 plus 4 is 53. Did you guys use the square root of 53? All right, so that's a good start. And from there, it's actually really easy. You just got to pick the right angle. I know some people pick the wrong angle. This angle right here is the important one, the one by the center of the circle. I guess I don't have a circle right now, but the one by the origin there. Okay, so then from that angle's perspective, the sine is opposite over hypotenuse, -7 over root 53. And the cosine is adjacent over hypotenuse, which is 2 over square root of 53. Okay, good. So that's the main thing from yesterday. There was one other kind on yesterday's, and it was about being coterminal. Would you find me 3 things coterminal with -45 degrees? You can use radians, you can use degrees that are going a different direction, or degrees that go further and then wrap all the way around, but you need a coterminal. See if we can handle that one. Okay, hopefully this one went pretty easy. -45 degrees looks like this, and you have a little arc going like that. Okay, that's where -45 is. So where are the other things that are like that? Well, you could go around this way, wrap all the way around here, and I allowed degrees or angles, so if I was going to wrap all the way around there, all the way to the back to here would have been 360, right? So it's 360 minus 45. So I believe that's 315 degrees. Anybody have that answer? All right, good. So 315 is an option. All right, what's another way to get there? Well, I could use radians, and I could say negative. What's the other way to say 45 degrees in radians? Pi over 4. My pi got a little weird there. Hold on a second. There we go. Okay. Yes?
So will it work to say the same thing but just one range or degrees and still has 2 different answers?
Good question. On a test, they would probably say your answers can only be in radians, and that'll prevent that from happening. You know what I'm saying? Most things on the test are radians. So, all right. So yeah, this technically doesn't count as 2 things. It's the same thing, just written, one in degrees, one in radians. Okay, but if I wanted to give them all in degrees, that would have been pretty easy too. If I did 45 and then the other one was 315, then I can always add 360 to the 315, because that makes 675 degrees, and that brings you to the same place, because that first 315 gets you here, and then another 360 gets you right back where you were. So you can always add 360 if you're doing it in degrees. What does that mean you could always add if you're doing it in radians? Instead of adding 360, that's like adding what? 2 pi. Very good. 360 is like 2 pi. So you could always take your answer of pi over, or negative pi over 4, and then add 2 pi to it. Actually, in this case, negative 2 pi, if you want to keep rotating the same way. All right, so enough on that. We have finally come to the day where you're able to figure out trig like you would normally have done with triangles, except for angles you could have never done before. In other words, if I were doing sine of 30, and I would get, you remember this one yet? 1/2. Good. Sine of 30 is 1/2. Why? Because I've got a triangle, and I go sine is opposite over hypotenuse and all that stuff. Okay? And we were always limited to doing that with things like the 30, 60, 90, where we knew this is 1, 2, and square root of 3, or things like the 1, 1, square root of 2 triangle. We could only do it for these guys. But now, after today, I can ask you to find, sine of 360 degrees. Things that aren't in a right triangle. All right, so there's two kinds. There's the kind like, let's make a relatively simple one here. That's supposed to be a 45-degree angle right here, which means this makes a 1, 1, square root of 2 triangle right there, right? Okay. But where is this spot? It's not really at 45 degrees. It's actually over here. It's that whole angle right there. So if I had asked the question, what is the sine of, let's see, 100 and, my brain is locking up. Is that 135? Is this 135 degrees? I think it is, isn't it? Okay, thank you. 135 plus the 45. Yeah, that would make a total of 180. Yes. Okay, so that's 135. So if I had asked you for what's the sine of 135 degrees, here's what you do. You know where 135 is. Well, I almost didn't for a minute there, but anyway, hopefully you could find where 135 was. And then you could say, okay, here's the reference triangle that goes with it. And I made one little mistake because I didn't include directions on my lengths of my sides. Somebody catch it? -1. This one's -1. This one's +1. Okay? Now, instead of doing sine of 135 and trying to draw this weird triangle that has a 135-degree angle in it, which would be like this blue one, we don't do that. But what we can do is find the sine of the reference angle that goes with it and use that answer. So to get the sine of 135, I'm going to act like they asked me to find the sine in this triangle. And the only angle you'd ever care about is the one by the center, the central angle. So if they ask me for sine of 135, I'm going to draw that little picture. That's what we did in the first test. You were asked to draw those, right? You're already pretty good at drawing those reference triangles. And now, for finding sine of 135, I'm really going to find the sine of this angle, 45. But it's not going to be exactly the same because it includes some negatives. Because if I just did sine of 45, I could go over here and make the 1, 1, square root of 2 triangle and say, okay, sine of 45 is opposite over hypotenuse, and so it's 1 over square root of 2. That would be wrong. The answer isn't 1 over square root of 2. It's close to that, though. From this 45-degree angle's perspective, it's opposite over hypotenuse. Oh, crap, it does come out the same. 1 over square root of 2. It just happens to be that way because we never used the adjacent side. So actually, it does turn out exactly the same as sine of 45, which comes out to opposite over hypotenuse. There we go. The answer is 1 over square root of 2. Yes? Okay, because of direction. If I just drew this xy axis and I said to you, this point over here has gone from the origin. To get there, you'd have to go -1, wouldn't you? I'll give you another one like it. Let's say I had this angle and it was 220 degrees. Well, it starts here, wraps all the way around, goes past 180 to 220. Now, if I'm going to draw the reference triangle for that, I just go psh, psh. Now, do you get that one of those sides, in fact, two of those sides are negative because of where it is? In that quadrant, this side's got to be negative and this side's got to be negative. because we're going to the left from the origin and we're going down from the origin. So those are both negative. All right, so if this is 220, I got it started for you. Would you please figure out the sine of 220 degrees? I'm asking for the sine of 220. So I got the sketch started. You'll need your reference angle because you never really can do sine of 220. But you can do the sine of the reference angle in that triangle. So start by just acting like it's the problem that we gave you on the first test. Make the reference triangle, okay? So here's the reference triangle. Figure out the reference angle. Well, if that's 220, that was 180 plus how much was this part right here? 30. So really, that's a 30-degree angle. Can I just go figure out the sine of 30 now? No. I have to figure out the sine of 30 on this triangle, which has negative sides in it. Okay? So if this is the 30, 60, 90, this must be the 60 then, right? And then the 30, 60, 90 has a 1 across from the 30, and then the hypotenuse is always double that, and then it's square root of 3 here. And I got to remember it's negative 1 and negative square root of 3. Now that I've got that all labeled, it'd be easy. 180, you're right. I didn't want 220, I wanted 210. This one wouldn't be something you would know the sides of. The angle, was it a 40-degree angle? Oh, man. Okay, I'm sorry. That should have been a 210, not a 220. Everybody just change that quick. It'll take 2 seconds. Make that a 210. And make that a 30. And if you were sitting there going, I don't know how to do sine of 40, you're right. You'd have to have a calculator to do that. But we're today going to only use numbers that when they're done, the reference triangle will come out to 30, 60, or 45. Or the quadrantals. And I haven't showed you how to do those yet. Like 90, like sine of 90. You can actually do sine of 90. When your teacher told you in the first place that you couldn't, it's just because they didn't want to confuse you with it. But you can do the sine of 90. And you can do this cosine of 90 degrees. So that 90-degree angle isn't totally off limits. You just have to have a special way of doing it. All right. Now that you've got this cleaned up, and I apologize, it was a sine of 210 degrees that you needed. So now I'm going to go, okay, I'm really not doing the sine of 210. I'm doing the sine of 30. And it's not just normal sine of 30. It's sine of 30 in this position with those sides being negative. So now I've got opposite over hypotenuse for sine, opposite hypotenuse, it's negative a half. How many of you had negative a half as your answer? Okay, good. All right, I'll give you another one. I'm more careful with my angle this time. Let's do tangent of 300 degrees. First thing you do is draw that reference triangle. Label the reference angle. Then you'll have a triangle starting to develop. Then you got to remember that one of your sides is negative. Pause for a second while you give this one a shot. Okay, so I hope you had a chance to compare and come up with an answer that looked kind of like this. Here's 300, leaving 60 left, right there, right? So then, how long are the sides? Can you tell? Well, yeah, you can, because it's a 60. That means this must be a 90, and this must be a 30. And you know how long the sides are. You got to be careful with our negatives, though. 30, across from the 30, you have a 1. See, over there, across from the 30, you have the 1. This is the 2, this is the square root of 3. And which one of them is negative? Square root of 3. That one's negative. If you forgot that, you would have screwed up part of the answer then. Okay, and then this is the important angle here, the reference angle. I can't really do tangent of 300 by itself, but I can do tangent of 60. Again, under the way we're doing it right now anyway, you need to look at this reference angle. So we go tangent from here. Tangent is opposite over adjacent, opposite over adjacent, opposite side, negative root 3. Over adjacent is 1, and why would I want to divide by 1? I would just mess it up. Negative square root of 3. Can you put over 1? Yes, but you need to simplify your answers all the way. So there you go. Raise your hand if you had that one right. Okay, good. Then you only have one thing left to learn. And that is, how do you do it when you can't draw a reference triangle? In other words, we've been still doing this based on triangles, right? We still end up drawing a triangle. This time, we're not drawing a triangle. All right, so this time, what if we needed sine of 90 degrees? All right, well, first of all, we still need to kind of go where it is. Where is 90? Well, we open up to there, and our line goes right there. You cannot draw a reference triangle for that. For all the ones you can't draw a reference triangle for, you have to do this based on the points. If this is a unit circle, if this is a circle that's going to go around and be a unit circle, meaning that it's a radius of 1 all the way around, then what are the 4 important spots? They are here, 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 and here. Those are the 4 places where if you go there, you can't make a reference triangle. And what are they labeled? This is 1, 0. This is 0, 1. This is negative 1, 0, and this is 0, negative 1. You might want to label one of those for yourself. These are the hardest ones. They're called quadrantals. And we usually put that kind of thing on tests. I haven't even seen the test. I'm just saying that we're not going to give you the easiest ones on your test. We're probably going to throw in some hard ones. So the question would be like this. Find sine of 90 degrees. Well, I know I'm here. Here's the cool part. It just involves these numbers right here. You just got to know whether it's 1 over 0, 0 over 1, or just 1, or just 0, or... All right, so now how do you decide that? I'm a big one on not just trying to have you memorize things like this. When it's something as simple as all students take calc that you learned the other day, ASTC, I just want you to memorize it. This is A, this is S, this is T, and this is C. That means that sine's the only thing that's going to be positive in this quadrant. Tangent's the only thing going to be positive in this quadrant. Cosine's the only thing positive in that quadrant. All of them are positive in that quadrant. Okay, that's the kind of thing you just memorize. For this next thing, I want to show you where it comes from. And I showed you on those too, but I want to show you where the answer comes from. All right, I have a nice construction I can show you that I think is going to help you understand this as best as possible. If we are in the unit circle, then how long would the radius be? 1. Okay, so that distance would be 1 right there, right? And I'm going to draw another one. How long would that one be? Also 1. Okay. Now, if I got to just the right place, this is just a 2-second review on what a radian is. If I got to just the right place where this and this and this arc right here are all the same size, do you remember what that angle is then? If this is 1 and this is 1, and this is 1, if all of them are the same size as each other, then this angle right here is 1 radian. That's the definition of a radian, in case you forgot it. I know I told you that back in the day when I first taught you radians. 1 radian is where the radiuses, of course, are the same, but where you force the angle wide enough open so that this arc length is the same length as these two sides. Okay, just a quick review of what a radian was. Here's another construction that's important for you to know. Okay, if I were to take this point right here and drop down to the x-axis, do you get how I kind of just made a reference triangle there? Okay. And this is the important angle right there, right? And if I don't know how long this is, I know it's less than 1, but how long is that right there? I don't know, so I put x. Okay? This height right here, I don't know how high it is. It's not 1, but I'm going to call it y. This, though, is still the radius, and we're still on the unit circle, and therefore it is 1. Okay? Now, would you agree that sine of any angle is the opposite over the hypotenuse? Then sine of this angle is the opposite over the hypotenuse. Y over 1, which since our radius is just 1, is just y. So the sine of the angle is the same as the y height of that point. Okay, now a lot of things you can in the end memorize where they came from. Sorry, not where they came from. You can memorize a trick that helps you remember it. And I've got a good one. Sine y. I think most of you would agree that sine and y, sine y, kind of go together better than cosine and y. Okay, so if you can just remember that sine is y, then cosine is the other thing. Think about it. Cosine's adjacent over hypotenuse, right? Here's adjacent, here's hypotenuse. Cosine is x. X over 1, but it's cosine is the x. Sine is y, cosine is the x. What's the tangent of this angle? Of that angle right there. What's tangent? Y over x. But it all can be memorized from sine y. Sine y. And this next thing I'm about to say sounds kind of dirty. Cos x. Get what I just said? Cosine x. All right? So cosine goes with x, sine goes with y. Sine y and cos x. Then I have tangent is y over x. How about this? It's kind of like the slope. Because y is kind of like the rise, and x is kind of like the run. Okay, so if you want to think of it that way, tangent is kind of like a slope. It's the y over the x. Okay, so what does that have to do with anything? I'm going to go back to this picture and say, what's sine of 90? Well, sine is y. It's the y. Well, what's the y? Well, look in this point. What's the y? So sine of 90 is 1. Now, if I actually made a picture of the sine curve and it goes like this, remember this? It goes up and down and up and down and up and down and up and down. Sine hits 1 at 90 degrees, or pi over 2. You'll be getting those graphs later. We'll teach you those graphs later, but sine is 1 at 90. All right. Let's do another one. How about cosine? What's cos? What's cosine? It's the x of it, and that's 0. How could cosine be 0? Well, because cosine starts at 1, and it goes down, and then it comes back up again, and its loop is just shifted from sines a little bit, but it's still one of those goes up and down and up and down and up and down. Okay, but it hits at 90 degrees at pi over 2, it hits 0. Okay, so then, if you're catching on to this, let's go over to this point. What would that be? 180. So sine of 180. 180. What's sine of 180? It's the y, which is 0. What's cosine of 180? It's the -1. Does cosine ever touch -1? Yeah, it goes down, all the way down and up. Goes from 1 to -1, and 1 to -1. How about tangent? I haven't done tangent now. I'm going to go back to this other one that we were doing for this. The tangent of 90 is the y over the x. The y over the x. 1 over 0, tangent of 90 is 1 over 0, and do you know what happens when you have 1 over 0? Undefined. Remember me saying that in trig there's a fair amount of times where you have answers that are undefined? Like if I say when is sine equal to 2, it never is. Undefined. When is tangent of 90, or what is tangent of 90? It's undefined. If you want to look at y, the picture of tangent looks like this. Tangent is a totally different kind of graph than sine and cosine. Okay, and it's at 90 degrees, which is also known as pi over 2. It doesn't exist. See, there's a dotted line right there. So there's a reason why tangent of 90 is undefined. All right, so if you understood that, we should be able to go to this point right here, which is also known as 270, down here. 270 or 3 pi over 2. So what if I said, what is the sine of 3 pi over 2, or also known as 270 degrees? Hopefully sine y is ringing in your head, and you go sine y is -1. There we go. Now, didn't I say before that these were always fractions? Well, you can put it over 1. You can take any of these answers I give you and put them over 1. And you get 2 sides of a triangle. One of my friends that teaches this says, so then basically it's kind of like a triangle. It has a side of 1 and another side of 1, and it has a width this way of 0. Anyway, you don't have to draw triangles like that. I think that's that can be confusing, so I'm going to stick with this way of teaching it. All right, so here's a point right there. First of all, label it with what comma what it is, and it'll help you to answer this question. What is the sine, cosine, and tangent of 2 pi? Because 2 pi is right there. By the way, it's the same exact thing as sine, cosine, and tangent of 0. Sine's y, cos x. Tangent is, hopefully you remember rise over run. It's like slope. All right, hopefully you said that point was 1, 0. Then, hopefully, you knew sine was y, so I just find the y of it, 0. Cosine's the x of it, 1. And tangent is y over x. Is 0 over 1 an okay thing? Yes. You just don't want 0 on the bottom. 0 over 1 is okay. It's equal to what? 0. So tangent is just 0 at 0 degrees. If you remember the picture I drew you of tangent, here's tangent. You see why it's 0 at 0 degrees? It hits 0, 0 on the graph. Okay. I don't know if that graphing stuff is helping you at all, but I know that this can be a little abstract. Sine is y. Cosine is the x. But that's the way Most of our teachers teach this, and it's a formula in trig that you'll have to get used to. Sine of the angle is equal to y over the radius. But since we're going to be in the unit circle pretty much all the time, the radius is 1, so y divided by 1 is just y. So sine is y. All right. So now you know how to do quadrantals too. So now I could ask you sine, cosine, or tangent of any multiple of 30, any multiple of 60, which would be multiples of 30, any multiple of 45, or the quadrantals, which are 0, 90, 180, 270, and 360. In your head without a calculator. All right, so let's start your worksheet. It is 4.3.1. Everybody find that on your iPad, 4.3.1. Sorry, 4.3.2. You're right. 4.3.2. That's what I meant to say. And here it is. 4.3, number 2. Cosine of 120. That's not one of those weird quadrantal ones. So we can go back to, how do you do these kind? You got to draw where 120 is. Picture's worth 1,000 words. Going to be hearing that a lot. 120 is about here. It's not the 45-degree angle kind. It's 260s. It's 2/3 of the way there. There's my 120. So then I draw this down and this over and say, okay, if that's 120 over here, then this one here must be 60. So then I know I'm in a 30, 60, 90 triangle. This is important. Across from the 30 is where the 1 goes, and that should get you started right. Across from the 30 is where the 1 is. That's where the 2 is. That's where the square root of 3 is. And then you got to remember your negatives. Which one of these is negative? The 1. Then I can now do cosine of the reference angle, which is the 60. So really it comes down to doing cosine of that particular triangle 60-degree angle. And cosine is adjacent over hypotenuse. So I almost said cos is x, and it wouldn't work in this kind of a problem. Okay, but cosine is adjacent over hypotenuse. Adjacent side is this one. Over hypotenuse is 2, so it's negative 1/2. How many of you had that before I said it? Okay, good. Let's do another one of they don't even do quadrantals in this whole section. By the way, I feel like there's enough in here, and we sometimes overdo the practice thing. Practice is awesome, but when I have to do it and it's actually due, and I actually collect the scores on it on Monday, I want to keep it reasonable sized. So let's skip, let's skip 8, 10, and 12 on this part. And in this next section, let's skip 16 and 18. Okay, this even labels, given the quadrantal angle theta, that's the directions that are up here for you, those of you that are at home, given the quadrantal angle, so it's telling you, these are the weird ones. Negative 450, what? Well, negative 360 would have been here. So 450, how much more is that? Another 90 degrees. So it's here. It's at that spot right there. So for this kind, you need the points. What's the point there? What, comma, what? 0, negative 1. Good. Now, if I want the sine, that's easy. Sine is y. So sine is y, and the y of it is negative 1. B is cosine. Cosine's the x, and that's 0. And the tangent of this angle. Tangent of TOA. No, I can't do TOA because there's no sides in this triangle. Tangent is y over x. The y is negative 1 over 0. What's negative 1 over 0? Undefined. UND. Or UNDEF, I see that more. Negative 270 is exactly in the same spot. No, wait. No, it's not. Sorry. Negative 270. Negative 270. It's up here. And that's at the spot what, comma, what? Somebody, come on. 0, 1. Good. And then if I have sine y, sine of it is the y, which is 1. Cosine of it is the x, which is 0. And the tangent of it is y over x, which is 1 over 0. Again, an area where we have a problem. Undefined right there. Tangent is undefined there. Okay. This next section, sadly, I feel like if I teach you, some of your brains are going to explode. So even though we need to learn that, I will teach you that on Monday. So you may, for now, don't like destroy them. Of course, it's digital. You can always erase it. But we are going to do 19 through 24. But I got to show you how to do that later. I sometimes have learned when to say when. So I don't want you going home all confused with the last thing. You'll get all depressed. So I'll show you that on Monday. All right. Get that part done that I asked you to do up through before number 19, and we skipped a few. And come back ready to go. Probably don't have time to collect the homework scores today, but I will collect those scores. Just you'll collect 2 at once or 3 at once someday soon. So keep track of your homework. That's all I got for you.